For the steering test, we use a floor. We need a space at least 4 by 4 feet on the ground. You can use the kitchen floor or the garage. To prepare that we can position the rover always in the same place, we use masking tape and put it on the floor with a small strip for the front wheel position. Make it short, about 1 inch long. And for the rear wheels, we put 2 strips where the rear wheels go. Use longer strips to see this is the rover position. And we mark in front of the rover about 2 or 3 feet with a straight masking tape. The rover is placed directly over the masking tape positions. And after we have the setup, we have a rover position, a starting position, and a straight track. And if we set the rover there, it faces the straight long line. After we have set up our track, we are now ready to do the steer test of our rover. We have loaded the Steer 2 program to the rover and we turn it on, and we find it is starting up correctly by turning the head and by showing the 2 dots for the steer test. We're setting the rover with a straight to the back rear wheel directly on our markings for the starting position, and we start the rover by pushing button B, which makes it wait, and then start. We see the rover is drifting a little bit towards the left. Now we're going to measure how far the rover has drifted to the left by measuring the distance between the front wheel and the center of the tape, which is about 3 inches for this rover. Now we are going to repeat the test, first without changing the steer. It should be doing the same thing, but we want to confirm this is true. We're taking the rover, making our front wheel straight, setting it on the same position, and let it run again. We see it is still drifting to the left, but immediately we also see it's not as much. Measuring how far the rover has drifted to the left, center of the front wheel to the center. Now it is only 1.5 inches. So now we are going to change the steer to find out if we can adjust that the rover is going to drive straight. We are pushing button A to set steer to 1 to the right, straighten the front wheel, set it back to the track, and we started with button B. And we see the rover is drifting to the right. We are measuring the distance, how far it has drifted, and this is about 1.5 inches, and we write this number down in our table. This is now steer 4, and let the rover run. And every time we do that test, we add the number how far the rover has drifted, in this case 3 inches, we enter that number in our table. So at steer 5, we are at 4.5 inches. Gives us 9.5 inches. Gives us 8 inches. 8 gives us 8.5 inches. 9 gives us 9 inches, and 10 gives us 9.5 inches. And we make sure we enter all our numbers in the table. We continue now our measurement to the negative side. We have programmed the rover, if we push button A again, it will start at 0. And the rover turns left by 1 inch. Now we need to distinguish between right and left with our measurements as well. So we call 1 inch to the left, we call this a -1. The -1 is what goes in our table. Pushing button A again, this will be now -2 for steer. And the rover steers 9 inches to the left. 1 more, 3 to the left. And the rover goes 10 inches to the left. Drifting 9.5 inches to the left. Dots to the left. Drifting 8 inches. 6 dots to the left. Drifting 11 inches to the left. What I'm going to show is how to enter the data and make a graph. You can do this on a piece of paper, but I will be showing this to you very quickly how you can do it in Excel. Excel is a spreadsheet program, and up here I have the steer variable, so that in that column I will have the steer variable, which starts from -10, gets larger and larger and larger, goes to 0, gets larger and larger and larger, and ends at 10. This is what we just measured by doing our steering test 2. And what we actually measured was the drift with a ruler in inches, and we're going to add the data into that column here. So what did we measure? We started at 0. Our first measurement was to the left, -1.5 inches. And you see automatically here in my graph, I got a point at 0. That's the value of the steer variable. But that point is a little bit below the line which is 0, because of course there is a negative value of negative 1.5. So in the horizontal axis, at 0, we go 1.5 inches down. That is our first data point. Our second data point was steer 1, the variable steer 1 to the right, and our rover went 0.5 to the right. So what you see is our second point is higher, of course, because 0.5 is larger than negative 1.5. And also the point is above the axis because 0.5 is a positive number. The next number was for steer 2, 1.5 inches. For steer 3, 2.5 inches. 4 was 3 inches. 5 was 4.5 inches. 6 was 5 inches. 7 was 9.5 inches. 8 was 8 inches. 9 was 9 inches. And 10 was 9.5 inches. So while we entered the data in our data table, we got points on the graph which simply tell what we knew from the very beginning. If the steer variable gets larger and larger, the rover is steering more and more to the right. But we also see that the 9.5 at 7 and the 9.5 at 10, those 2 points are at the same level. So something happened here, that we had an error in our measurement. Now, we have an error in our measurement all the time. You see those points are not perfectly on a straight line, but at least we see the trend and we can see immediately what our rover does with which kind of steer variable. Let's complete our table. After we measured the largest positive value, we went back to 0. We only can enter one number. We remeasured this one. And then at negative 1, we got a negative 2 inches. And again, we get another point at negative 1. Between 0 and negative 2 is negative 1, which is down by 2 inches. And when we continue at negative 2, our value was negative 9. At 3, our value was negative 10. At 4, we got another negative 9. At 5, we got a negative 8. At 6, we got a negative 11. At 7, we got a negative 12. At 8, we got a negative 14. At 9, we got a negative 13 and another negative 13 at negative 10. So what we see in our data is that although we see correctly the overall trend, the perfect behavior of our rover is actually not quite reliable, and sometimes it turns a little bit more to the right or to the left than it should be doing. This is normal, and this is what we can expect from our motors, which are not perfectly the same, and that affects our steering of our rover. With this, we have completed the calibration of our steering of our rovers. Does your table look approximately the same as my table looks like?